For A, to find the volume of the rectangular prism, we're going to use the base area times the height. This piece right here is the top view. So the base area will be 10 by 10, and the height is 12.5. I'm going to change it to the decimal version. So it'll say times 12.5. The base area is 100, and we're multiplying it by 12.5. So the volume is going to be 1,250 centimeters cubed. Volume is 3-dimensional. All right, so I'm just going to write that for part A, and then I'll erase so we have space for the rest of the parts. All right, part B says calculate the volume of the triangular prism. Again, all prisms use base area times height to find volume. The base area of a triangle is 1/2 the length times the width, and then we need to multiply that by the height. In this problem, we have a length of 5. Whoops, that's supposed to say 1/2. A length of 5 and a width of 2.5. The height of this triangular prism is the same as the height of the rectangular prism. All right, so we're going to do 1/2 times 5 times 2.5 times 12.5. 5 times 2.5 is 12.5. And 12.5 times 12.5 is 156.25, which is 1/4. And then we want half of that, which is 78.125, or 78 1/8. And that is also measured in centimeters cubed. And again, I'm going to erase this just so we have some more room for the rest of the problems. C says calculate the volume of the material remaining in the rectangular prism. So if we were to take the entire rectangular prism and then eliminate that triangular prism, how much is left on the outside in between the triangular prism? So if we were to shade this section in here, how much is taking up this space? And so to find that, we're going to do 1,250 minus 78.125, which gives us 1,171.875 centimeters cubed. D asks about how many rectangular prisms can fit, or how many triangular prisms would be cut from a rectangular prism. So we can think of this as a rectangular prism has maybe 12 cubes, and a triangular prism has 2. How many sets of 2 would fit into 12? And so we're just going to divide. We'll take the rectangular prism's volume and divide it by the triangular prism's volume to tell us how many equal pieces we can fit inside. And so if you were to calculate that out, it comes out to 16 triangular prisms. E is asking what is the surface area of the triangular prism if we don't have a bottom or a top. So we just have a front, a right, and a back. So front, right, back. And the front is a 5 by 12.5, because it's 12.5 tall. The right is 2.5 by 12.5. And the back is 5.6 by 12.5. And if you calculate those, the front is 62.5. And this is in centimeters squared because it's an area. The right is 31, oops, I still have the eraser. Is 31.25 centimeters squared. And then the back is 70 centimeters squared. So for part E, we need to add 62.5, 31.25, and 70 together. Which is 163.75 centimeters squared. So that is the surface area. The surface area.